Hello respected tutors and mentors. My name is Sarthak Mansi. I'm currently studying level 6 at ISMT College. This video is about presenting my prototype of customer segmentation model. So let's begin. These are the user libraries that will be used like pandas, macrolin, numpy, shiba, python, etc. We use the data which is stored in the customer CSV. There are 20 rows and 5 columns now in my data set. This is a summary of the data where this is the summary of the data where mean age is around 39 years. Mean age is around 39 years. Median age is around 26 years. Mean age is around 18 years, whereas max age is 70. The mean of the annual income is around 6,000, whereas median is 65, very close to each other. Minimum income is around 15,000 and max is 1,000. Mean of the spending score is 15. Median is also around 15 and it spans between 1 to 90. There is no missing values. Let's do a exploratory data analysis. I created some bins so as to understand the age group and number of males and females within age group. So if I see a maximum number of males who are present in my data set belongs to age group of 30 to 35 and 35 to 40 respectively. Two ranges are between 30 and 40 and are the most number of males so far. As female lies between the age of 30 to 35 and then comes 20 to 25 and then 45 to 50 and of course 35 to 40. So this is my distribution of males and female in terms of age. Now if I look into percentage of males and females, so out of 200 observations which we have 87 males and 112 females, that is 44 and 56% respectively. It is more on the female side rather than on the male side. If I look at the distribution of annual income with respect to gender, the number of males which have annual income between $70,000 to $80,000 is higher than 60 to 70, whereas in case of female, it is 70 to 80, which is very similar to males. And at the end, if I do a box plot of annual income, the median annual income is slightly higher than the median income of a female. This is the graph for median income of males and female customers. Correlation graph. Here the slope is negative. Then there is a negative correlation between age and spending because the gender is for the plot. With the increase in the age, there will be decrease in spending score. People around 70 spend less across both the genders compared to customers 20 years old. Looking at the clusters, we use 4 different clustering algorithms to test the dataset. We first start with K-means algorithm. To find the appropriate number of clusters in K-means, the L method we use. For this case, the number of clusters between 2 to 10 will be calculated. The rule to choose the number of clusters with king or n algo can be seen in the graph. Below the graph shows the selected range of clusters. There is no clear elbow visual. Also, the 5 or 6 clusters seems to be here. This is the class for selecting, so we can see that when it comes to 6 clusters, it gives me the highly excellent score. This gives me a clear idea that we might get a better result when we have 6 clusters. So let's implement first the 5 cluster and then implement 6 cluster and compare them both. This is the graph for the 5 cluster. When it comes to A's, we hardly see any cluster getting formed. It is pretty scattered, so it is quite disturbed. But when it comes to N, we can see with the internal 5 clusters. There are no distinct clusters when it comes to A's. Sizes of the clusters. Below is the 3D projection of 5 generated clusters. Let's implement this. Here we implement the 6 clusters, and we can see that again when it comes to A's, the same result is found. Cluster are found, but not very good enough to better distinguish between the cluster. When it comes to 6 cluster, the K-means cluster of 6 cluster is not performing that well as compared to 5. If the 2 clusters overlapping each other in 6 clusters, these are the results generated by the 6 clusters. Pretty much evenly balanced clusters equal the number of observations belonging to each clusters. Coming into the TB scan. TB scan graph. I can see it's not performing well with respect to A's, but when it comes to annual income, it is performing well. If you see the small black dots, these are the actual outliers. When we apply the mean shift, we do not have to give anything. We do not have to give anything because it takes care of everything on its own, and we can see. And this time we have not taken the A's within all the 3 algorithms. It didn't work well. So I have only taken the annual income. This worked perfectly well. It has created the 5 cluster on its own. I have not given anything, so it understands the data and created 5 cluster on its own. It seems to be little scattered on this side of as you can see, cluster 0 has equalization, others are pretty okay. Agglomerated cluster, when it comes to agglomerated cluster, it almost gives the same result with 5 clusters. Here is the mean shift because we have done it for 5 clusters. These are the dendrograms. There are 2 different dendrograms. Within, we have using the linkage method, compute and average. In this case, we can use other linkage method to see how they performed. We are trying to figure out. Sorry for the disturbance again. We are trying to figure out the very sample size. If you bring all the clusters size equals all the errors in a table, we can observe that which is performing the best when we talk about k-means with 5 clusters. One of the cluster has 79 observations, whereas when it comes to 6 cluster, we have pretty much evenly distributed observation across the cluster. So between these 2 k-means algorithm, 5 and 6 cluster, I would go for k-means 6 cluster. When it comes to DB scan, the first cluster have 12 observations and 18 are outlier, which means it takes 130. Rest 70 observations are part of the remaining full weight. There are 2 clusters, one with 8 observations and another with 4 observations, which is pretty much not evenly balanced cluster. When it comes to mean shift, it performs very similar to the K-means cluster. The values are more or less the same. It has come up with the same size 5 cluster from the K-means, and all at the end, when using agglomerative, this is again not giving good results. We have chosen 5 cluster for the agglomerative result. So from all this, we can conclude that by far K-means cluster this gives me a more evenly balanced cluster in terms of the size of the system. In terms of the size, because the most important point across all the algorithm, DB scan works extremely well when it works with a large number of samples. This is the model customer segmentation, where I have segmented the customers as per the annual income and spending scores. The age results are not very good. The model was fine, but I could have done better. This model couldn't handle the dynamic data. Is data used from the static model CSV. I will enhance the prototype later, and this is all about my prototype development of the customer segmentation app. Thank you.